Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about functions of random variables or transformations of random variable. In the processing of random signals, it is often necessary to transform a set of random variables to another set of random variables. If the input is a set of random variables, the output should be a set of random variables. So now here in this section, we study the techniques for obtaining the probability distribution functions for the set of output random variables given the transformation and the probability distribution function for the set of input random variables. These transformations are also called as functions of random variables. The transformation of one random variable into another random variable is called one-to-one transformation or monotonic transformation. So one-to-one transformation is also called as monotonic transformation. So consider two random variable x and random variable y. So one random variable transformation of random variable x into another random variable y is called as one-to-one transformation, which is also called as monotonic transformation. Let capital X be a continuous random variable with probability density function fx of x and capital Y be another random variable with probability density function fy of y. So the probability density function of another random variable y is related to random variable x by the transformation y is equal to g of x. So the transformation g is called the monotonically increasing function, and the monotonically increasing function condition is if g of x1 less than g of x2 for any x1 less than x2, that is the condition of the transformation g is called as monotonically increasing function, and the transformation g is called monotonically decreasing function if g of x1 is greater than g of x2 for any event for any x1 less than x2. So this is shown in this figure, and this is the graphical representation of monotonic increasing function or monotonic increasing transformation with the function g of x1 less than g of x2 for any x1 less than x2, and this is the graphical representation of monotonic decreasing transformation g of x1 greater than g of x2 for any x1 less than x2. And first we are going to discuss about monotonic transformation. So monotonic transformation is also called as one-to-one transformation. So now here this is the graphical representation of monotonic transformation or one-to-one transformation. Here consider a one-to-one transformation of a random variable x to another random variable y, which is shown in this figure. So given that now here the one-to-one transformation, the transformation function is y is equal to g of x. We can also write y plus dy is equal g of x plus dx. So which is approximately equal to g of x plus dz by dx into dx, where dz by dx is the derivative of the function g of x with respect to x. So now consider the event. That event is small y less than capital Y less than or equal to y plus dy is the y. So consider that event. So from this figure we can observe that the event y less than or equal to y plus dy event contains the same outcome as the event x less than or equal to x plus dx. So accordingly, the probability of these two events, and what are the events? One event is y less than or equal to y plus dy, and another event is x less than or equal to x plus dx. So the probability of these two events must be equal. So that is probability of probability of event y less than or equal to y plus dy is equal probability of x less than or equal to x plus dx. So this equality may be written in terms of the probability density function. But we know that the probability is equal to density function. So this equality may be represented in terms of the probability density function. So this LHS term is equal to Fy of y into dy, and this RHS term is fx of x into dx. Here fx of x is the probability density function of the random variable x. Fy of y is the probability density function of the random variable y. If the function g of x is a monotonically decreasing function, so now here this equation indicates that the function g of x is a monotonically increasing function. So if the function g of x is monotonically decreasing function, that relation we may write fy of y dy is equal minus fx of x dx. Therefore, in general, we rewrite. So from the above two equations, what are the two equations? Monotonically decreasing function equation and monotonically increasing function equation. So generally we can write fy of y magnitude of dy is equal fx of x magnitude of dx. So this equation is called as conservation of probability in one-to-one transformation from a random variable x to another random variable y. Defined as a function of the random variable x. So dividing this equation by dy on both sides, we get fy of y is equal to fx of x into determinant of dx divided by determinant of dy. So therefore fy of y is equal to fx of x divided by determinant of dy by dx. So this is the formula for one-to-one transformation of a random variable. This is the concept of monotonic transformation or one-to-one transformation. And next we are going to discuss about non-monotonic transformation. So the non-monotonic transformation is also called as many-to-one transformation. Sometimes the transformation may be non-monotonic and also called many-to-one transformation. So that means several values of x can be transformed into only one value of y. So this is the graphical representation of many to one transformation. So consider the figure in this figure in which the equation the transformation y is equal to g of x. So the transformation y is equal to g of x has three roots. That three roots here we have to consider x1, x2, x3 are the three roots. By the similar procedure mean in the same manner of the monotonic transformation. So we have y is equal to g of x. So that y is equal to g of x. We may also write y plus dy is equal g of x plus dx. So which is approximately equal to g of x plus dz by dx into dx, where dz by dx is the derivative of the function g of x with respect to x. So now here there are three roots. Since the equation has three roots, that are x1 plus dx1, x2 plus dx2, and x3 plus dx3. So we write the probability of the outcome is equal to summation of the probability of the three roots. So that is p of y less than or equal to y plus dy is equal probability of x1 less than x less than or equal to x1 plus dx1 plus probability of x2 less than x less than or equal to x2 plus dx2 plus probability of x3 less than x less than or equal to x3 plus dx3. Assuming the three events are mutually exclusive in terms of their corresponding probability density functions. The corresponding probability is equal to density function. So from this equation, the probability of this LHS term is density function into dy. That is fy of y dy. And on RHS side, the first term is density function into dx1 and the second probability is density function into dx2 plus third term is density function into dx3. So the RHS term of this equation may also be write sigma k is equal 1 to 3 fx of x fx of xk determinant of dxk. So dividing on both sides by dy, we get fy of y is equal sigma k fx of xk determinant of dx by dy, which is equal to, so this dx is coming to the numerator. We have RHS term is sigma k fx of x k by dy by dxk. So this is the formula for the many to one transformation of a random variable.